In the case of single input production technologies like those in Chapter 11, there was only a single way that a producer could produce any given level of output efficiently. But once we introduced two inputs, labor and capital, we gave rise to the possibility of many different ways of producing a given level of output. This in turn gives rise to the possibility that producers will choose to substitute labor for capital or capital for labor as the underlying economic conditions change or as the input prices change. And this in turn gives rise to substitution effects much like the ones we found in consumer theory. We'll explore some of those here. We begin with a homothetic production technology that has initially increasing but eventually decreasing returns to scale. In other words, a technology where the isoquants are such that along any ray from the origin, the technical rate of substitution remains constant, and where the numbers associated with the isoquants are such that they initially increase at an increasing rate but eventually increase at a decreasing rate. With an initial wage of $20 per hour and a rental rate of $10 per unit, the slope of the isocost is -2, and we'll assume that the cost-minimizing way of producing 100 units of output is to use the production plan C, which uses 7.5 hours of labor and 15 units of capital. This also implies that the cost-minimizing way of producing any other level of output must lie on the ray that contains point C, because the homothetic nature of the production process implies that along this ray all the isoquants have a slope of -2. Now suppose that the wage falls to $10 per hour. This implies that the slopes of the isocosts will go from -2 to -1. In other words, the isocosts will become shallower, which further implies that the tangencies between isocosts and isoquants will occur on the shallower portions of the isoquants. The new ray that contains all the cost-minimizing production plans at this new wage rate will therefore be a shallower ray than the one we had before. The new cost-minimizing way to produce 100 units of the output is now given by the production plan C', which occurs at the tangency of the new green isocost and the blue isoquant that represents 100 units of output. So we now use 10.6 hours of labor and 10.6 units of capital to produce 100 units of output in the least cost way. You can tell that this costs less than the original production plan C, because the isocost that goes through point C and has the same new slope lies further out and therefore requires a greater level of expenditure. Since we know that all the initially cost-minimizing production plans were on the steeper ray from the origin in panel A of the graph, we can use those production plans to calculate how much each level of output would cost initially when the wage was $20 per hour. This gives us our initial cost curve when the wage was equal to 20. For instance, production plan C required 7.5 units of labor and 15 units of capital. At $20 per hour for labor and $10 per unit for capital, that implied an expenditure or a cost of $300. Each of the other points on this ray can similarly be used to calculate the dollar cost for producing the level of output that's associated with each of the isoquants in panel A. This is graphed in panel B with output on the horizontal and dollars measuring costs on the vertical axis. When the wage falls from $20 per hour to $10 per hour, the firm would experience a decrease in its costs even if it changed nothing about how it produced output. In other words, even if it continued to produce on the steep ray from the origin in panel A, its costs would fall because every hour of labor that it hired now costs less. For instance, the input bundle C, 7.5 units of labor and 15 units of capital, would now only cost $225 rather than the $300 it cost before the wage fell. This initial drop in costs is often referred to as the direct effect on costs of a decrease in one of the input costs. But it's not the only effect on costs, because the firm will in fact change how it produces output as a result of the changed economic circumstances. In particular, we've shown in panel A that the firm will substitute away from capital and towards labor for any output level that it chooses to produce. As a result, there's an additional decrease in costs that emerges from the substitution effect, the effect that says use more of the input that's become relatively cheaper and less of the input that's become relatively more expensive. The picture in panel A would look identical if instead of thinking about a decrease in the wage from $20 to $10 per hour, we thought of an increase in the rental rate from $10 per unit to $20 per unit. In both cases, the slope of the isocosts would change from -2 to -1, in one case because the wage fell, in the other case because the rental rate increased. And in both cases, labor therefore becomes relatively cheaper and capital becomes relatively more expensive. Thus, in both cases, we see a substitution effect away from capital and towards labor for any level of output the firm might decide to produce. In panel C, we can then show what happens to the cost curve as a result of an increase in the rental rate, and we start with the initial cost curve that occurred when the rental rate was 10 and the wage was 20. Notice that this cost curve is initially steep, becoming shallower and shallower, and eventually becomes steeper and steeper. This is because along the steep array from the origin along which production occurs in panel A, the production frontier has the shape of initially being shallow, becoming steeper and steeper, but eventually becoming shallower and shallower. In other words, initially having increasing returns to scale and eventually decreasing returns to scale. We showed in chapter 11 that the shape of the production frontier along which production occurs is inversely related to the shape of the cost curve that emerges along that production frontier. Since one of the input prices increased, the cost of producing any level of output will go up. For instance, the cost of producing 100 units of output was initially $300 when we used the input bundle C, and now that we switch to input bundle C prime, the cost increases to $424 when the rental rate is $20 and the wage is $20. The new green cost curve then represents the new cost curve that arises from producing along the shallow array in panel A. It's less, however, than the cost increase would have been had the firm chosen not to change its behavior. The magenta dotted line would be the cost curve if the firm continued to produce on the steep array in panel A. Therefore, there's a direct effect on costs that takes us from the blue cost curve to the dotted magenta curve, and then an amelioration of that effect because of the substitution effect that leads our costs not to increase by as much as it would have had we not switched from the relatively more expensive input to the input that's become relatively cheaper. Another way of thinking about the substitution effect when the wage falls is to think about what happens to the labor demand conditional on producing a certain level of output. For instance, in panel A we showed that if the firm is producing 100 units of output, it will initially hire 7.5 hours of labor, but eventually will switch to hiring 10.6 hours of labor when the wage falls. So we can plot the relationship between the wage and the labor demanded, assuming that the firm will always produce 100 units of the output. This is referred to as the conditional labor demand curve because it's the labor demand assuming the firm continues to produce 100 units. It's not the actual demand curve for labor because as economic conditions like wages change, firms will adjust how much output they produce. It only shows how much labor demand will change as a result of the substitution effect, assuming that the firm continues to produce the same amount as it did before. It's technically similar, in fact it's technically identical, to what we call the compensated demand curve in consumer theory, where that was the demand curve that isolated substitution effects. In the same way, the conditional labor demand curve isolates substitution effects for producers, and it's downward sloping because as input prices change, we should always experience a substitution effect towards the good or the input that's become relatively cheaper and away from the good or the input that's become relatively more expensive. In panels B and C, we derived cost curves and how those change as input prices change, assuming that the firm can vary both capital and labor. In other words, we graphed the long-run cost curves, and from these we can derive long-run average and marginal costs. We begin with the long-run average cost curve, given the initial wage of $20 per hour and the initial rental rate of $10 per unit of capital. The slope of the long-run average cost curve is the marginal cost curve, and we plot the portion that lies above the long-run average cost curve because that's the portion that represents the firm's long-run supply curve. When the wage falls, average costs fall, as do marginal costs, and they fall more than they would if we simply assumed that the firm didn't change its behavior by adjusting the mix of inputs. You can view the dotted magenta drop in the average cost as a short-run drop in the average costs that occurs simply from the drop in wages without a change in the behavior by the firm, and the drop to the green curves as the long-run change when the firm re-optimizes what it does given the new economic conditions. Here we've drawn the lowest points of the average cost curves as occurring at the same output level, but that's not necessarily the case. Depending on the underlying technology, that lowest point could shift to the left or to the right. The initial blue average and marginal cost curves in panel F will be the same as in panel E because they're derived from the same initial cost curve that occurs with a wage of $20 and a rental rate of $10. Notice that the lowest point of the average cost curve is plotted around 100 units of output. If you're interpreting point C in panel B on the initial cost curve as the inflection point along that cost curve, that's actually not quite right. That would translate to the lowest point of the marginal cost curve. The lowest point of the average cost curve occurs past the inflection point when the marginal cost curve crosses the average cost curve. The increase in the rental rate causes the long-run average and marginal cost curves to shift up, and with it, the long-run supply curve shifts as indicated by the portions of the marginal cost curves that are drawn. The increase in costs, however, could have been higher had it not been for the substitution effect. If the firm had continued to operate on the slice of the production frontier that's represented by the steeper ray in panel A, the average cost would have risen to the magenta level. The firm is therefore able to mitigate some of the impact on its costs of the increase in the rental rate by switching away from capital and towards labor. Notice again that here we've assumed that the lowest point of the long-run average cost curves remains at the same output level, but that's not necessarily the case. How that point shifts, whether it shifts to the left or to the right, depends on the underlying production technology. We showed in panel A that if a firm has a homothetic production technology, it will operate along a single ray from the origin for any given set of wages and rental rates. We can therefore think of the firm as operating on a slice of its three-dimensional production frontier, a slice along a ray from the origin. The shape of that slice will determine the shape of its cost curve. If the shape is such that it has initially increasing but eventually decreasing returns to scale, we get cost curves that have the shapes that we've drawn in panels B and C, and an average and marginal cost curves of the shapes that we've drawn in panels E and F. As input prices change, however, the firm will switch to a different ray from the origin, in other words, a different vertical slice of its production frontier. But so long as that slice still has initially increasing and eventually decreasing returns to scale, the essential shape of the cost curves are maintained. The size of the substitution effect, however, will be determined by how much these curves are shifting. If an input price is falling, the firm can do better than it could if there was no substitution effect, and therefore the substitution effect adds to the downward shift in the cost curve. If, on the other hand, an input price is increasing, the firm can ameliorate some of the impact on its costs by using the substitution effect, and therefore the increase in costs won't be as much as it would be in the absence of a substitution effect.